Hi, welcome once again to the Moj Math and Science. In this question, we're to find x raised to power 3 plus 1 over x given x squared minus 7x plus 1. Let's get started. Now, we're given x squared minus 7x plus 1 to be equals to 0. And my examiner wants us to solve for x raised to power 3 plus 1 over x. Now, I want us to attend to this carefully. Now, look at it very carefully. You see that where we're going to, or what we're solving for, is x raised to power 3 plus 1 over x. I have x squared minus 7x plus 1 to be equals to 0. Now, what do I do to make this format of this question look like this? The first thing I think I should do is divide through by x. Now we're dividing through by x, so that if I divide all through by x, it becomes x squared over x minus 7x over x plus 1 over x equals to 0 over x. Now, x here cancels x here cancels one of the x here, so I'll be left with x minus 7 plus 1 over x to be equals to 0. Anything divided by 0 is 0. Now you look at it carefully, it's beginning to look like what we have here. So that is, I have x plus 1 over x. 7 is going to come to this side to become plus 7. X plus 1 over x is equals to 7. Now what do I now do again to this particular equation to make it look like what I have here? This is my target equation. Now the next thing I think I should do is to raise the power of both sides of this equation to 3, so that I have x plus 1 over x raised to power 3 to be equals to 7 raised to power 3. Now if I'm raising x plus 1 over x raised to power 3, I need to expand this. It could become a little bit clumsy, but let's use the binomial theorem and we'll use Pascal's triangle. Now the Pascal's triangle tells me that if I have 1 here, I have 1, 1, I have 1, 2, 1. I will explain. 1, 3, 3, 1, and it continues that way. Now, this is what Pascal tells me. This is where we use them. Take, for example, if I'm expanding something like this, if I'm expanding x plus y raised to power, probably I'm expanding raised to power 10. It's very high. Now, the Pascal's triangle helps in such expansion. But now we're expanding to the power of 3. That is why I stopped at 3 here. This is the first line of 1. Now, to expand x plus y raised to power 3 using this particular triangle, each of these figures here become the coefficient of my expansion. How do I mean? Now, this is x plus y. Instead of me expanding this to x plus y, to multiplying it 3 times and doing x plus y raised to power in 3 places, my Pascal's triangle will make it easier for me. This easily becomes, this is 1, this is 1, x raised to power 3, y will be raised to power 0, plus 3, x now will reduce in power by 1 to raise to power 2, y will be raised to power 1, plus 3 again, the last coefficient which is 3 here. Now we'll now pick x now again, will be raised to the power of 1, y now will be raised to the power of 2, plus the last coefficient here is 1, x now raised to the power of 0, y will be raised to the power of 3. Now, so that the final expansion becomes, this is 1, x raised to the power 3, that's x raised to the power 3, anything raised to the power of 0 is 1, so y is 1, plus 3, x raised to the power 2, y, plus 3, x, y squared, plus 1 again, times x raised to the power 0, that's 1, and this is y raised to the power 3. We'll use this same expression to solve this question. So that x plus 1 over x raised to power 3 will be the same thing as x raised to power 3 plus 3 into x raised to power 2 into 1 over x, because that is our y now, plus 3 into x into 1 over x squared plus 1 over x, all raised to power 3, is equals to 7 raised to power 3. What's 7 raised to power 3? That's 7 times 7, that's 49, times another 7. 7 times 9, that's 3, that's 63. We carried 6. 7 times 4, that's 28. 28 plus 6, that's 343. So that this is 343. Now this is x raised to power 3. X raised to power 3 is already standing on its own. X raised to power 3. You know, in this where we are going to, we actually need x raised to power 3. Plus x here is 1. X here is 1. I have 3x left. Plus x here is 1. X takes 1 here. I have 3 into 1 over x plus 1 over x cubed to be equals to 343. So that this implies that, this now implies that x raised to power 3, I have x, if you look carefully, I have x raised to power 3 here, I have 1 over x raised to power 3 here. Let's collect them together. X raised to power 3 plus 1 over x raised to power 3. Now, plus, I'm left with 3x, and I have 1 over x. If you come down here, you see that this is looking like this. Now, if I bring 3 out, I'll be left with x plus 1 over x is equals to 343. Now, this implies that x raised to power 3 now plus 1 over x raised to power 3 plus 3. Now, let's replace the whole of x plus 1 over x with 7. That becomes 7 times 3, that's 21, is equals to 343. So I can authoritatively say that x raised to power 3 plus 1 over x raised to power 3 is equals to 343 minus 21. Let's subtract 21 from 343. Here is 2, here is 2, and here is 3. So that leaves my final solution to be the same thing as 322. So x raised to power 3 plus 1 over x raised to power 3 is the same thing as 322. Thank you, and do have a nice time.